Hello everyone, it's April 14th. Alright, no problem, let's go for it. Partition list. Okay. Given the head of a linked list. Oh, it's linked list. I like linked list. And a value x. When the partition is such that the nodes less than x come before the nodes. I'll do it again. All nodes less than x come before nodes greater than or equal to x. It should preserve the original relation order of the node. Isn't this the quick sort? So basically, to implement one step of quick sort to partition. I remember in a list, this can be done by swapping, right? Oh, can we swap? No, you cannot swap. And it has to be a value, right? And find a value. And then all nodes less than x come before nodes greater than equal. So given this, and if our target is 3, so everything smaller or equal to 3 goes front, and larger than, it's not strictly, I mean it is, right? It is partition, so we pick a value, all right? I'm thinking about the regular list, right? Pick a value, and then what we do, we just we swap it to the front because it's easier, and then we have the remaining, then we just swap. If it's front and back, right? Front if it's smaller, we just move forward, and the back if it's so front we're gonna keep going until we end with the value that's bigger than the target, and from the back we're gonna keep going until we find a value that's smaller, and then these will swap. After swap, we keep going and swap, and then eventually we will be right. And then at the end we swap with the target, and then we will have it. Yeah, that's the regular way of doing a list. I mean, we can definitely turn this into a list, but not gonna do it that way because that's just cheating. So if we have 3, we also have to preserve the original relative order of the nodes, which means it cannot do 3, 4, right? Interesting. Very interesting. 200, no value, so now unique. So let's just see. If it's 3, we find 4 is bigger than 3. So what? 4 needs to go. Hold on. I think we should do is insert the value that's smaller to the front. For example, we have 3, right? So we find the first one that's larger or equal to 3. We mark it, and then we keep going. If it's larger or equal to 3, then it's fine. If it's smaller or equal to 3, then we will cut this out, insert into the front, right? And we keep going. And then every time we find something that's smaller, then we insert. Well, in order to insert, we need a front and a current. So we have to go with 2 at the front. One is the dummy, the other one is our target. And then we're gonna go until we find the first one that is larger or equal to the target value. And we're gonna record this value. We record the back, the pre. We don't care about, we do care about this, but we care more about this, the pre. And then, actually we don't care about this, we only care about the pre. And then this one can keep going. Every time we find something that's smaller, and then we're gonna cut it out. Oh, how do we cut it out? You need this to cut it out. right? Well, how many do we need? Well, we need, how do you cut this out? You have to know this and this. So what we're gonna do is we have a pre and current, right? So current, when current is the first one, we're gonna break out. So we make sure we have the pre unchanged. And then from this position, we're gonna keep going. And when we go, we're gonna check the next, right? We always check the next. If the next is good, we'll move forward. We check the next. If the next is not good, then we can cut. We cut the next out and put the next in the front. In the front, we have the pre, so we can insert it there, and then we move the pre forward. And this one, keep going. Ooh, keep going. Actually, no, we have to check the next. And then now keep going, we check the next. Oh, we can cut the next out front and then check the next. I think that's the solution. Doesn't really require too much. I don't think there's any tricks in this. Just straightforward. I think a little bit of manipulation of the nodes shall suffice. Shall suffice. All right, let's take a look. I mean, again, this is no, wrong. Press the wrong button. This is the linked list, which means we do not do our testing unless it's absolutely necessary. Okay, so we need a dummy. So we're going to for a dummy. Dummy is going to be a list node. I don't care about value, but I care about the next. And then we're going to say pre and current equals dummy and head, right? And what we're going to do is while current dot val, while current, right? While current, I'm going to say if current dot val is larger or equal to x, then we break. Otherwise, current equals current.next, dummy, not dummy, pre equals pre.next. Right, so this one will bring us to the first value that is bigger than x, right? We'll bring it here, then we break out. So pre, we do not change anymore. Now from the current, we're going to say while current.next, right? While current.next. So we know current.val, so this one definitely will be good. And range, it could be 0. So it could be a none. So this one will get out, and then while, yeah, I guess I have to say while current and current.next, just in case, right? So what we do is if current.next.val is larger or equal to x, then we say current equals current.next, right? Else, if it's smaller, then we need to cut, right? So here, so current is here. Current.next.val is smaller than x, so we need to cut this one. How do we cut? We're gonna call it a temp equals current.next, right? And then we're gonna cut it by saying current.next equals temp.next, right? Current.next equals temp.next. So we cut this one out, and we're gonna insert it in here, so it's pre, right? So we say temp.next equals pre.next, right? Pre.next is this one. Temp.next or pre.next. And then pre.next equals temp, right? And we're gonna move pre equals pre.next. move pre forward, and that's it. Going back, we still stay. Our current doesn't move, so we can still keep checking. And this is good, so we move forward. And then we're gonna cut this on again, right? And current on next is none, so this one will cut next to none. And the temp on next will be the pre-order move forward. That's good. And we move pre-forward. That's fine. And we go back up. Current is here. Dot next is none, so we break out. And we're gonna return dummy.next. That's our head. All right, take a look. See if this one works. Run code. This one works for this. I think another 2-1, right? Yeah, 2-1. Oh, it should be 2. 2. It's good. How about 1? We're trying to test all the edge cases. Should be good. And then 0. It's empty. Empty shall return empty. How long do I have to wait? I thought I waited enough. Yep. Okay, let's try it. Submit, pending, accept. No, not even judging part. Okay, so that's that. Let's say straightforward solution. We look for the first node whose value is larger than x. Then that node determines where future smaller nodes will be inserted. Then we keep moving forward and cut the node that is smaller than x and insert it at. Okay, look for the first node whose value, that node determines where the smaller will be inserted. Then we keep moving forward and cut the node that is smaller than x and insert it at the front. Insert it at the inserted right before the first node that is bigger or equal. Yeah, it's larger or equal. I just say this. That is this x. Keep doing this until we hit the end. ON solution, and probably, oh, we have a solution for this. Oh, I've done this before. Wow, it's a long time ago. 2019. That's during my internship. 36 milliseconds. What is the runtime? 54% ranking. Fine. Yeah, done this before. So it's a medium question. That's all right. 2-pointer approach. That's the only approach. For quick sorts, you may have a very hard time. It's very difficult. Terms linked list, not arrays. Oh yeah, if you're swapping, it is hard to maintain the order. Do we have the same solution? I don't remember. A reform list 1x joined. It's called this point joined. 2 pointers before after to keep track of the two linked lists is described. Ah, I think it's different from mine. Could be used to create two separate. They're creating two separate linked lists, and these lists could be combined to form. Oh, okay. Okay, I see what it's doing. So basically, it is creating two, and then if it's smaller, we are going to push that here. If it's bigger, we're going to push to the end. And when it's done, we merge these two together, combine together. Okay, that's fine. That's fine. That's a good solution. I like mine. I like mine. There's a lot of cut and paste, cut and paste. But I think this basically is the same idea. Let's implement it. Let's implement it. It's interesting, right? I'm trying to see what I mean. It's easier in terms of your mental. You don't have to think as hard. Like this part, you probably need to make it a little bit more explicit. Like first is cut, right? So this is cut part, and this is the paste part. Right? So cut and paste, making sure that we're clear. And this is official solution. It is not any better than than solution one. I think it's not any better than solution one, but it does require less mental effort. Okay, so I'm gonna do left and right. So basically two dummy nodes, right? So it's gonna be list node and list node. All right, so we have a left and right, and then we're gonna traverse. Let's say node equals head, while node, if node dot val is smaller than next, then left dot next. Oh, we have to also node equals head. No left, no right. Left, right. Right, so has to be no left dot next equals node. Right, no left dot next equals to node, and no left. Oh, hold on. Yeah, we do need no left equals no left dot next. Right. Else no right dot next then equals node. No right equals no right dot next. And we keep going, so we're creating two separate linked lists. And we also have to do node equals node dot next. Right? So again, node is smaller, so we connect it to node, and then no left equals next, or no right equals next, and then we node will go to the next one, and then hold on. I think we need to cut it out first, right? We need to cut it out first. So while node, how do we cut it out? Node on next equals node, right? And node equals, we do, so either this or this will actually be on node, and node will move on to the next one. For my current node dot next, will it suffer? So as I'm putting here, I mean I can copy it, right? Copy is definitely not gonna have any trouble. But if I don't want to copy, if I'm just pointing here, right, and I want to move this to here, and cut it. So anything happen here will not affect anything happen here. If I don't cut it, this one will leads to this. And my node is here, and if we say this one pointing here, then this is this is complicated. Which means after we move the node, because when we do this, this one's already on the node, so we need to move node forward. So we need to have a temp. Temp equals node. Node move on, and temp.next equals none. Right? The temp will be either this or this, so it'll just be none. And then we can keep adding. And when we at the end, right? When we at the end, both these are at the end. So NL and R will be at the end. So all we need to do is node left dot next equals right dot next. Right dot next. And when we return left dot next. Right? So this is the solution. Take a look if this one is correct. So I'm gonna go console, use example test case. Actually, we can create more and also empty. Gonna run. Input your output expected. Yeah, I think this one's correct. Yep, this one's correct. Same time. So yeah, this one is fine. So here is important. Must cut the link. Otherwise, must cut the link between. Must cut a link when a node goes to left or right. Cut the link when a node goes to left or right. Yep. All right, that's it. I think did pretty well. Discussion. Oh, it's 86. That's why I did it before. Yeah, I remember those days. Those days are I'm doing one LeetCode per day, which exactly is the same as right now, but I was just following. Yeah, he uses 2 pointers. Yep. Wow. I think it's almost the same. He did not make any changes. He did not do this. Oh, I guess it's fine. It's just hard for me to rationalize that way. But anyway, we got it. We got it. 2 different solutions, both works. All right, that will be it. See you guys tomorrow. Adios.